In Chapter 1, when we looked at inequalities, we had inequalities with one variable. Since we only have one variable, these types of inequalities were one-dimensional. A one-dimensional graph only goes left and right. A one-dimensional graph is really a number line. So when we graphed inequalities with one variable, our graphs were on a number line. In this case, -2 was my critical value. And to decide if I colored in this dot or I left it open, I looked at, do I include -2 as a solution? Well, in this case, yes, I do, because it's or equal to. So I'm going to shade in the dot, and then I want to shade all the values where n is greater than -2. Well, greater than -2 would be to the right. All of the values to the right of -2 are greater than -2. Like 0 and 1 and 2 and 4, all of those values are greater than -2. When we look at example 2, we have two variables in our inequality. To graph two variables, we need a two-dimensional graph. A two-dimensional graph is really taking a number line going left and placing another number line going up and down. When we place two number lines, one going left and right and one going up and down, we end up with the Cartesian plane. So to graph this inequality, to find the solutions of this inequality, we're going to first graph this line. To graph this line, I'm going to solve for y. Now when I multiply both sides by -1/5, I need to flip my sign. So I'm left with y is less than +2/5 x minus 2. Now if you look, by solving for y, I've switched my inequality into slope-intercept form. Originally I had my inequality written in standard form. And by doing this math and keeping everything equivalent, these two inequalities are actually equal. This inequality is the same as this inequality. So any xy value that works in this inequality is going to also work here. To figure out what ordered pairs x and y work for this inequality, I'm going to graph this. My slope is 2/5. My y-intercept is -2. So I'm going to go down 2, and from there I have a slope of +2/5. Now I'm going to put dots all the way across my graph. So I have my dots going all the way across my Cartesian plane. The next thing that I need to do is kind of like up here where I had to decide, do I want to shade in the dot or not? I need to decide if I want to connect these dots with a solid line or a dashed line. Now all of these points are all of the x and y values that when I plug those values in, I will get exactly 10. Or if I plugged in the x and the y values here, the left side would exactly equal the right side. If I look at this ordered pair right here, 0, -2, if I plug in 0 for x and -2 for y, I end up with 10 and 10. If I plug in 0 for x here and -2 for y, I end up with -2 and -2. So the question is, do I want to include these points as possible solutions to my inequality? is 10 greater than 10? Is negative 2 less than negative 2? Well, technically, since I don't have this or equal to, 0, negative 2 is not a solution. So in order to represent that on this graph, I'm going to connect these dots with a dashed line. A dashed line is like an open dot. It means don't include this value, but include everything right up to this value. Don't include the points on this line as a solution, but include everything right up to that line. Now I need to figure out which side to shade. In one variable, it's easy to decide. N has to be greater than to the right of negative 2. In two variables, I've really divided my Cartesian plane into two regions. So I need to figure out, do I need to shade here or here? So I'm going to test a value. I'm going to test the point 0, 0. I'm going to plug 0, 0 either into here or here to decide if 0, 0 is a solution. I'm going to take 0, 0 and plug it in right here. 2 times 0 minus 5 times 0 has to be greater than 10. 0 minus 0 is 0, is greater than 10. Is 0 greater than 10? And the answer is no. So the point 0, 0 is not a solution to this inequality. So this line divides my Cartesian plane into two regions. 0, 0 is not a solution, so I don't want to include it in my possible solutions. So I'm going to shade, but I'm going to shade to not include 0, 0. I want to include the values on the other side of my line. Now, much like a number line, the shading represents all my possible solutions. So any ordered pair that's in the shaded region is a possible ordered pair that makes this inequality true. So if I pick this point right here, this point right here is 2, negative 3. 2, negative 3 is a solution to these inequalities. If I pick this point down here, which is 1, 2, 3, 4, 5, 6, negative 6, negative 8. Negative 6, negative 8 is a solution. If I plugged in negative 6 for x and negative 8 for y, I'd end up with a true statement. The reason I picked 0, 0 to test is 0, 0 is really easy to plug in, and it's a point not on my line. If my line went through 0, 0, all I would have to do is pick another point to test.